Aloha, everyone. Thank you for uh, for stopping by this Thursday afternoon. Apologies, I'm running a little behind schedule. Work called a little late, so give me a couple of seconds and we'll get up and running. Make sure I got my Q&A and just the chat. Good to see everybody here. Andrew, Corey, Ethan, Jim, Professor Nitz, Lee, and Major Lorian. Good to have you. I'll wait a few more seconds to see if we get anybody on, and then we'll get going. Excited to hear Tom's deep dive this afternoon. Colonel Shimori, good to see you. And some, I feel like the updates never end, which is good. That means that we're constantly seeking more information and better guidance and refinement of the process. It's just hard to keep up with at times, especially COVID and COVID vaccinations tend to blur together. So trying to keep that level-headed for everybody and to make sure everybody's on the same sheet of music. So with that, I'll get going and start today's Thursday community meeting. So as always, we start at an international overview, remembering that this is for Hawaii, so we really focus on Japan right now. Eventually we'll throw on Korea, as Korea was recently added as a trusted partner for international travel into the state. But at a country level, Japan is trending down. Hopefully this will continue to go, for those who are avid Olympic fans. I know that that's still up in the air in terms of whether or not they'll be able to execute, and obviously how this impacts us in terms of travel. At a national level, continue to see this downward trajectory, which is great. However, once again, this needs to be tempered by the fact that the UK variant, the B117, has been found in over half of the states, and the South African strain, I think, has made landfall coincide, and so that needs to be monitored closely, even especially since we're still in the colder months in the mainland, and there's supposed to be an Arctic super cold weather front coming in, so forcing people back indoors. So keeping that in mind at a national level. For our state level overviews, continued positive positive notes on our decreasing trends on cases for Arizona, California, as with Nevada and Texas. So once again, these are all great signs, and hopefully this, in addition to the increases in COVID vaccinations, will help us get to a safer place sooner than later. Moving on to our Hawaii overview, state level perspective, our cases per 100,000, we have now reached a point where majority of the counties are under that 10 case per 100,000. Maui is close to returning under that benchmark in terms of percent positivity. Once again, Maui is trending down, which is great, and the rest of the counties are holding steady under 3%. And I think that's a positive sign. And 3%, we get, we think 3% is bad, but if you compare to some of the other countries and locations, we're doing well, even Maui County. So once again, everything is relative. So just want that to be in the mind of everybody. Moving on to COVID vaccination, because we know how that is tied into transmission and the whole COVID situation in the state. We're in phase 1 Bravo or phase 1B. We increased, there's a difference of 12,000, a little over 12,000 vaccinations. This was pulled 2 days ago, or data from 2 days ago. So we're at a total of 171,000, give or take, vaccinations cumulative. And then you can see, I think this metric is updated weekly, so it's a little lagged. but you can see that we're continuing to trend in the right direction. In terms of doses administered, we're doing very well in terms of getting shots in arms and not letting the vaccine sit in a freezer. And once again, understanding that this data is lagged. So, you know, it's harder to get a sense of the pulse if you just look at this. So this slide in conjunction with the previous slide gives a pretty good viewpoint of where we are as a state, hoping that our partners at DOH will release data that will provide a little more granularity in terms of first doses versus fully vaccinated with that second dose. So we can start to figure out what percentage of our population is quote unquote fully vaccinated with either the Moderna or the Pfizer vaccine. Testing turnaround time, once again, is great, and you know, with our prevalence, our disease circulation stabilized, this continues to be less of a major variable, but it's always good to keep in mind and see what we're doing at a weekly interval. Going to HiPAM's forecast, focusing on the blue and the red for those who may be new to our webinar series, where our red is our pessimistic and our blue is our realistic. No, you can see there's not much difference, and that's because of all of the variables that we account for in terms of clusters and you know, travel. We're really projecting for the next 2 weeks a very steady trend in our cases, and then by default, by translation, our hospitalizations, ICUs, and deaths will follow suit. And for those who may not be aware, all of these other, let me use the pointer, all of these gray lines refer to the CDC's ensemble, which I believe Tom will speak to a little more. But this kind of gives you an idea of where all of the other models and projections have Hawaii. Once again, there's a little more nuance to that, but that's just to give you kind of the left and the right limits on where people expect Hawaii to be and where we have been. So we fall, you know, pretty much in line with the average if you were to average out all of these trends. And here's a slide that just speaks to what you saw previously, just in a numerical format. I'm not gonna spend too much time, but just for those who like to look at numbers, this is available on our HiPAM website. Like I led off with, there's always so many highlights, even with just the variants alone. And if we have some particular questions, please throw them in the Q&A chat, even if we didn't talk about a topic, and we can save it. And if I can't answer it, I'll push it out to all the experts, part of the HiPAM working group, and hopefully we can get those questions answered. But two that I wanted to focus on, these were within, you know, these are less than 48 hours in terms of the release to the public. The first one is a preprint, or sorry, it's a preprint of a submission that has not yet been peer reviewed of the AstraZeneca, and I'm glad I see Andrew on the net to see if we can speak to this a little more in terms of the proposed efficacy based on a single shot, and also some conclusions that the authors have drawn in terms of efficacy based on certain dose intervals. And the second link refers to a study utilizing some mathematical modeling and some morbidity data from certain states to look at estimates which age groups are responsible for the majority of the sustainment of the transmission. So it's the first highlight is a preprint with the Lancet. Once again, it's not yet been peer reviewed. It's in MedRix, but basically they're showing. I'll start with the table on the left, which looks at the efficacy of the AstraZeneca vaccine after 2 doses, and basically what is on the left-hand side, the row values, is trying to tease out the efficacy based on the time interval between the first and the second dose. And if you look straight at the vaccine efficacy, the first conclusion is that, man, If you have less than 6 weeks between the first and second dose, the efficacy is about 55%. But if you wait greater than 12 weeks, which is about 3 months, 90 days, that efficacy increases to about 82, 83%. One thing to note is that if you just were to look at the percentages, it's a big difference, but you look at the raw numbers, and then the comparisons between the case, the control arm versus the intervention arm, there are some differences, even though we try to compare versus percentages, and it's hard to extrapolate based even on this, the sample size of this phase trial, really how much we can take this at face value. And Andrew, if there's anytime you want to butt in or interject, please do so, especially if you disagree with anything I'm saying. But I would say that it's encouraging, but we really still can't, what some of the news outlets are saying is that, we should wait 3 months between shots. I'm not sure if that's what the FDA is gonna recommend in their EUA, but this is what the data is showing. Andrew, if there's anything you want to add right now?
Yeah, hey Thomas, this is Andrew. So this was from phase 1, phase 2 data regarding this. And usually phase 1, phase 2 data is, was this phase 1, phase 2 data or phase 3 data? Phase 3 data?
I believe this was phase 3.
Yeah, this is kind of unusual too, right? Because phase 3 data usually is not the dose ranging study or the interval study. So it was kind of bizarre that they had this in it, in my opinion, that they had a differences in this. Based off of this, I'm not quite sure what the FDA will do. I don't think the FDA has ever been presented something quite like this, where it's their determination to decide. Most likely, AstraZeneca will propose what the dosing interval should be. And they should be very cautious, because this is the kind of data that got poo-pooed by the FDA previously. Because if you take a look on the right-hand side as well too, with the table 2 efficacy of the vaccine after a single dose for the symptomatic, you see between 90 to 120 days of vaccine efficacy for one dose 2 is 32%. 61 to 90s, 78%. Their single dose efficacy looks, quote unquote, better than their 2-dose efficacy. And a lot of people are going to scratch their heads and ask why. And so this is the kind of data that wasn't looked very highly upon by the FDA in the first place. So this might muddy the water a bit. I have to read about it a little bit more. I know this was just released today.
Yeah, just to add to that, Andrew, and please add on afterwards. The single dose is concerning from, for those that want to read a very long paper. Dr. Fauci and other, and so this was this study was written mainly at the Imperial College of London, but a big limitation to the single dose data is that it wasn't it wasn't randomized, because the intent wasn't to look at the single dose efficacy, but they did it anyway because of everything that's been going on the past month or two with the vaccine logistics, and potentially maybe just giving everybody a single dose and waiting for the logistics to catch up. So there's potential confounding, and I listed here that because of the fact that it wasn't double blinded and it wasn't randomized, that it increases the possibility for confounding by other variables that might, like you said, Andrew, muddy the results from that single dose. So that's why I wanted to bring it up, because if you just, for the majority of the population that just reads the news, they're going to think that this is such a great product. But you go into the weeds a little bit more, then like Andrew pointed out, it's not as good as it seems. And I know AstraZeneca previously, a couple months ago, got kind of poo-pooed by the FDA. So go ahead, Andrew, if there's anything else you want to add, please go ahead.
Yeah, so I took a quick look at the preprint of the study, and usually its interpretation kind of dictates what the intent is for the approval. And they're trying to go with the angle of, everyone's trying to go for a niche, right? Their niche is that because of the interval, our strategy is, because of the shortage, you can give one injection out. Take a look at how good our one injection is. Take a look at our 2, which is which we think is really good too. And we're going to say one dose is great. They'll provide you some protection for now. And while the supply is being ramped up, you can wait 3 months for your second dose. So they're going to push for the 3-month one and try to market it that one dose is good and okay. 2 doses would be ideal, but you can wait it out as supply builds. So it's a really risky strategy. I don't know, like marketing wise, I don't know if the FDA will like this data.
Mm-hmm.
I am very, they might approve it just for a 12-week regimen, but they're going to raise some questions too about one dose. Well, they're going to push for the 2 dose. I'm pretty sure the 2 dose with the 12-week interval.
Yeah. So I agreed, and I think just like with anything COVID, we need more information, but and I haven't spent as much time as I would like to kind of dig into a lot of these vaccine efficacy calculations, but the fact that they're using Poisson models, and not going to get into it here, but I don't think that when you're trying to manipulate a lot of the data, that doesn't bode well for some of the straightforward answers that we're looking for. So once again, just bringing to everybody's attention, because this has been, at least in my current job and situation and circles, there's a lot that's been talked about. And I know if people read the news, they're going to think, with such a great product coming down with Johnson & Johnson, we're going to be saved by the summer and we're going back to normal. And once again, to echo Dr. Fauci, we need to still be cautious. So understanding how this impacts people's behavior. Second one, talking about behavior. There was a study that was published yesterday, 2 days ago, in Science, where their objective was to try to utilize mobility data and synthesize that with mortality data from 38 states and 2 cities, District of Columbia and New York City, to try to determine which age demographics were responsible, or to try to look at the transmission and sustainment of transmission of COVID. And they did it by age category, and their results, their major findings was that within the 20 to 49-year-old age category, the majority of COVID-19 infections both originated from and were sustained in this age category. And so one big note is that, for all of our data friendly enthusiasts here, association does not equal causation. And once again, you cannot prove that mobility itself directly accounts for the entirety of the mortality data, though they mention all of their caveats and limitations in their study. But once again, all people look at is the 1 or 2 sentence blurb that summarizes it without looking at the limitations of the study. So just worth pointing out there. But some important takeaways is that as we move into the summer and we get more people vaccinated, but still understanding the hurdles with logistics and the supply chain, that mask wearing, especially in these demographics, will continue to be important, and messaging and education for mask wearing, and also behavioral changes, and encouraging to get vaccines once they're in that phase 2 population, to encourage them to get vaccinated will be important to reduce transmission. So those are the 2 highlights for our participants, attendees. If you have any questions, please throw them in the Q&A. But with that, I want to make sure I give enough time for Tom to give his talk. So with that, I'm going to stop sharing, Tom, and go ahead and if you want to share your screen, if you have that ready. If not, I can always be your Vanna.
Sure. Let's see here, share screen. Thanks for the invite, group. This was something I put together for a colleague at HiPAM. Marguerite's got a graduate course this spring for COVID modeling. She reached out to us to see if anyone wanted to come and talk story. And so I told Thomas, hey, I can come talk story about this for you guys as well. Share screen. And PowerPoint. Thomas stood this up. Gosh, Thomas, was this March or something when you stood this group up, HiPAM?
Victoria stood this up, I think. I think March, mid-March, and then everybody jumped on board, and it evolved to what it is today. So once again, it's not one or two people; it's collaborative, and then also our attendees too. So, but yeah, coming up on a year, it's crazy to think a years passed so quickly and or slowly. So,
Amazing,
but
yeah.
yeah, please take it away.
And I know you were doing HiEMA, right? So you were, I know, well, the modeling started with your sphere model you picked from HiEMA. Is that correct?
Yeah, that's correct. So, for those who may not know the entire backstory, and I'll keep this very, very brief. HiPAM was started by Dr. Fan and everybody, and Marguerite and Tom and Lee, and in parallel, um, a couple weeks later, I was brought on to be the lead forecaster modeler for ESF8 under HiEMA. Because there was no state-specific forecasting, and we very quickly realized that whatever models were trying to be applied to Hawaii were so off base because Hawaii is unique, and then let alone you look into Maui or Kauai or Hawaii Island. So having to stand up something from scratch, and that was a process in of itself, and and that's where the work with HiPAM really came to save the day, because one brain is never enough, and then I'm not a modeler by training, so literally the entire COVID response, especially for forecasting for Hawaii, has been building the plane or ship as we are trying to ride it. So that's just a backstory, and thankfully we have our wonderful experts part of HiPAM to take whatever they want and to spread the information that they have and the education. So that's just a background for everybody who's attending that doesn't know, that wasn't aware of HiPAM. But Tom, thank you for being a core member, and excited to hear your talk today.
Absolutely. So yeah, I think I came on in May. I think I caught an article on you from UH and thought, hey, how fabulous. And my graduate degree is in biostatistics. I spent a year in the Graduate School of Public Health at San Diego State doing epi classes, but it was all chronic disease. So when I started with IPAM and we're looking at these SIR models and SEER models, just like Yosh, I think I first talked to Yosh like, gee, I have to go look at these. I've never been exposed to these before. And they're such a niche, right? So they don't happen very often. It's been 100 years since someone had to really kind of play with things. So my background's really not with these transmission models. My background's more with business models. I've taught a couple MBA classes for quant. I'm helping out with UHMC's business class now. We touch on autoregressive models at the end of that 300 level class. And so I thought I would, and a couple of the main models are using autoregressive models, and people are using them across the globe. And they're really relatively simple models. And if you can, you want to keep it as simple as possible. So I thought I would try to present something a little different here. And so this is an autoregressive model. So I think I got this from CDC. And of course, we can see on the graph the actual data, and then this cone of uncertainty, and all the different models. And then over to the right, you can see an ensemble. We're taking some sort of weighted average of all these different models. And there's so many people doing so many modeling, and so many, it's really a fabulous time, horrible time for humans, but a fabulous time for modelers. And there's such a value as you here in Hawaii, we're only building out a week or two out. So, the uncertainty is not so, and the error is not so terrible. But if you're like University of Washington and you're trying to forecast out 6 months or a year, your cone's getting pretty big. So to have help and to build an ensemble and then to weight that and help bring that in a bit is really valuable. An ensemble model compensates for relative weaknesses in individual models while reinforcing the relative strength. And there's a lot of math behind all this, a lot of proofs. One of the classics is an UMView, uniformly minimum variance, unbiased estimators. So this nice little weighted mean here is just saying that's our best, right? So if we run out to CDC, and in the early days, this is kind of what most of us probably did. We walked out and we looked at what's everybody doing. And there were so many different universities and groups, think tanks, building models. And in the early days, they had what type of model they were using here. They've reworked this so it's kind of harder to find. Is this an agent-based model, or is this a Bayesian hierarchical model, or is this a SEER model or SIR model, or so many different things going on. It's really interesting work, machine learning. This other website here, GitHub, it's a little easier to see the different models that are going on. And again, most of the same ones that CDC are using here. So if we walk down, here they'll have their methods, right? So the first one, and their alphabet is tied. So the first one's a SEER model, which is what we're using here in Hawaii. But if you go down a couple here, you'll see Carnegie Mellon's using an autoregressive model, which is what we're going to talk about today. A couple more down, maybe. I think Facebook's got an ensemble model where they're using a machine learning model mixed with the autoregressive model. So people are using autoregressive models, they make sense. Just wanted to jump in and talk about that a little bit. So that's what we're doing here, an autoregressive model. And George Box is one of the classics in statistics and math that talked about modeling. And I think Fauci kind of quoted part of this, the positive part. You know, sometimes these models are useful, right? And George talks about they're always going to be wrong. And the question is, how wrong? And one of the issues we find is we overfit, right? So as scientists, and you know, we want to be as perfect and optimize as much as we can, and we've got to look out for overfitting quite often. And then the other side of this is underfitting, just you know, some kind of too simple of a model. There's a nice little sweet spot in there. So quite often we have trend models. To get to a trend model, you got to gather some data, and we're really lucky here that all that hard work of sourcing and cleaning data is done by Department of Health for us. Obviously, that's maybe 70% of the work we'd spend our days doing. So it's pretty easy to, and I think most people have done this, but let's just take a look. We could just run right out to the DOH website, map right into their epi curve. How fabulous is all this is done for us. And then my wife is teaching upstairs, so we're sharing bandwidth. We can download their CSV file that they've created for us. And I think they do this by county. So today I'm going to present on Honolulu. And so here we've got a number of fields. The first one's county. I'm just going to kind of clean this up, take away well, just a minimal amount of wrangling here, take away Hawaii. And leave only Honolulu. Again, that's because that's the only one I'm looking at today for you guys. Okay, we've got some missing data. It's never a good thing. Okay. And, oh, we have Honolulu now, so I can even lose that field. Okay, a little data wrangling. Let's keep it as clean as possible. It's all Honolulu, and now that field's gone. We only really care about your time steps, your dates, and your cases. So these other fields, let's get rid of those too. So this is what I'm reading in. Marguerite asked for a presentation for her students, something they could chew on, something, and she wanted it in Python. And so, you know, in the days of my modeling days, Python's rather new. Mainly I use SAS. So this last year I've had to kind of come up to speed on Python, and luckily it's such a great little easy language to prototype pretty quickly. I'm just going to take off some zero values here so we don't have a little issue. Again, more cleaning. Okay, so that should be good. Now, we're just going to grab this data really quick, and we're going to plot it. Okay, so this is what we saw June through now, Honolulu data. And most of our time in HiPAM, or a great deal of our time, we're standing around going, what do you think? You know, what happened here, right? So we opened up, right? And the disease started to show up, and then we closed down, and then a holiday showed up, right? And then we kind of shut that down a bit. And then guess what? More holidays are showing up. And, you know, we really don't have multiple years, so we really can't talk about seasonality really well yet. We could talk a little bit about trend. And as I'll reference in the end, Facebook's come up with a model called Profit, which incorporates outside of a seasonality component or a cyclic component, a holiday component, because we're really definitely seeing that, right? So these blips are, you know, 4th of July or summer events where people got a little too relaxed. Again, you know, Christmas holidays and this Sunday, Super Bowl Sunday, and we're all crossing our fingers that we don't see, you know, with our disease median up here, you know, more of a exponential jump in a couple weeks post that. If we want to just kind of start with the most simple model, we're just going to fit a line and talk about that. And you know, I'm not sure about everybody's background, but one of the first things we talk about when we're modeling is an R-squared, a coefficient of determination. And really in a layman's way, what that's saying is that the change in your response variable, your vertical axis, how much of that is explained by the change in your horizontal explanatory variable down here. And you can see a linear model is really poor, right? Not very good. So you can, Excel is nice. It's, you know, for prototyping really quickly, look at data. You can look at an exponential fit, a log fit, polynomial of multiple orders, power, and of course, what we're using quite often is a moving average. So you would think that we should see, given this disease and the transmission models, an exponential fit is going to be a better fit. Yes, it made a big jump in our R-squared here. And a power function would be a good fit too, maybe even better, but they're, you know, similar animals. Polynomial. So here's a second order polynomial, and it's not as good of a fit, but what if we went to a third order? Well, now it's a better fit than that exponential. And what if we went to a fourth or a fifth or even a sixth order? Well, look, we've even made a big jump, but what have we done? We've over parameterized maybe, right? So that's the thing about overfitting. You may be able to get marginal benefit in your R-squared, your explanation, but again, you've overfitted it, and the future is probably not so overfit. So I just wanted to briefly talk about that before we jump back in here to autoregressive. Okay. Right. Okay, so got your data, you've cleaned your data. And again, the backdrop for this is for Marguerite's graduate students, so they have something to play with. When I first got involved with Python a year ago, or maybe a year and a half ago, and Deb Shish asked me, hey, can you do this? Like, sure, this sounds like fun. There's so many working environments, right? That's one of the hardest things to choose is, you know, what's my environment I'm going to work in? I think I ended up with something called Anaconda, and within Anaconda, it had a Spider IDE, and I've been kind of utilizing it. It's also got a notebook in there too. And if for the students, I kind of put a link in here for them. So within Python, one of the most valuable things about this Python is it has all these libraries. I remember 30 years ago when I first got into this stuff, right? And we had to code everything ourselves, a whole lot of loops and a whole lot of if then else statements. Nowadays, you can just call up a routine and it will just do it all for you. It's just so fabulous. You just kind of, to some degree, got to understand what it's doing. So we're gonna use a library called Pandas, matplot library, NumPy, stats models, and PMD ARIMA, which is they have an auto regressive. It'll go through a bunch of different scenarios for you and pick the optimal one. Again, how fabulous, hours and hours saved. So here I'm just, and I put the code on the side here for Marguerite students so they can, again, copy this into the IDE and play with it a bit. And we're just reading in what we just did in Excel, our reported cases. Now this is going to be a univariate model, right? It's only got one variable. We're only going to talk about past cases to try to predict future cases. If we wanted to build a multivariate model, which we'll talk about at the end, you can bring in all these things that Thomas is talking about, right? Mobility data, masking data, travel data, all these different variables, all these different parameters. It gets complicated fast. And I know when I'm talking to other modelers, you know, you can see their headaches. So again, this is supposed to be a really simple model. Okay, so an ARIMA model. So ARIMA model is gonna add the benefit of an autoregressive and the benefit of a moving average. It's gonna integrate these two. And here's the mathematical equation to this, right? So how many x of t, how many cases are we gonna have tomorrow? Well, we're gonna have some error involved in that because tomorrow hasn't happened yet. This is what your E of t is, the error component. And then the summation component here is going to be, well, what's happened today and yesterday and the day before? Does that have some value, right? That's your autoregressive component. And it does, of course. I mean, we can likely see that, you know, what happened yesterday is going to have some effect on tomorrow. And then we have a component here for your moving average. So moving average, if we look back yesterday, we can say, what was our forecast model say? Call it X hat, Y hat. And then what was the actual, right? Y. And then if we take the difference of those, we have an error term, right? So can we use that error from what we found yesterday, day before that, to make our today model or tomorrow model better? And that's our moving average component there. So we're just building the simple univariate model here on those components, okay? There's a lot of underlying conditions for all of this. One of them is that your data needs to be stationary to use an autoregressive model. So when we looked at this data here, we could see it's not stationary, meaning it's all randomly bouncing around a mean. We're seeing some trend here. So we can do some techniques to adjust for that, some transformations, if you will. So there's a whole lot of math behind all this kind of stuff, but we need to test for stationarity. The graph kind of shows us anecdotally that it's not, but you can actually do some tests on this, some hypothesis tests, get some p-values to help you make a decision. So this is the original data, and this is the code over here, and we're doing a augmented Dickey-Fuller test, is what it's called. And the p-value for the original data, that's not a very small p-value. So we're gonna say it's non-stationary. And then we can look at the autocorrelation graph here too. And you can see it's not bouncing naturally above, looks like the mean's about 0, but it's not bouncing naturally up and down. But if we take the time step differences between today and yesterday, difference that data, and now model just the differences, now that's what we're seeing here, a first difference. And it looks like it's all bouncing around 0, mean of 0. So that's what we want to see, stationarity. I'm not going to go into the variability here. What we'd also want to do is look to see if the variance is constant, right? You can see that during periods it was, and then something happened. We locked down, and then it was stationary for a while, and then something happened, a holiday. And then it was kind of similar during that period. And then, you know, so there's different mixture periods, if you will. And I just wanted to keep it simple for these grad students where we didn't start logging all the data, differencing, and just all, you know, you just go on forever in depth. So it was an introduction. So we're gonna go with this first differencing, and we're gonna look at the autocorrelation here. And you can see it's bouncing around. And then they have bands, confidence bands on this. So this kind of graph is gonna help us decide what parameters we should fit our best model. And the idea is that in this graph, if your lags are outside of the confidence interval, then they're significant and you should maybe include them in your model. So, and again, if we did the same hypothesis test, the augmented Dickey-Fuller, you can see the p-value here is relatively close to 0. And so the first difference seen is stationary, at least for the mean. Okay, next slide, we're kind of blowing those graphs up a little bit, and we're looking at, okay, how do we pick our P, D, and Q? P is our parameter for autoregressive. What order, you know, 1 step back, 2 step back, how many steps back of data are going to be significant to help us build this model. D is a differencing. We've decided to go with a one difference. And again, if you had nonlinear, maybe a quadratic thing going on, you might difference more than once. but it starts to get a little too complicated. So we're just gonna go for the single distance here. Your Q is your parameter for your moving average. And again, how many steps back are helpful? This autocorrelation function and partial autocorrelation function, these graphs are going to help us pick these steps here, these parameterization. The first one, autocorrelation here, is going to help us for picking the moving average steps. And you can see there's a jump, big jump here. So at least we're going to use the first lag and maybe a second lag. Some of these are significant, but again, you know, as you move too many on, the marginal benefit is not so great, right? So you don't want to over parameterize again. And as you move way out here, you can see how, you know, the pass is maybe really not helping us for today because so many things have happened. The partial autocorrelation is for your autoregressive terms. And this is a little harder to read, but again, you know, we use graphs at first, and then there's tests to do with those. Okay, next graph is, we decided to go with a really simple model, just an auto-REMA 111. So we're including the autoregressive, just a single lag, and you can see it in red. We're including the differencing, single difference, and we're including a single moving average. And let's just take a look at that. And again, all the code for the students here to play with. And we can see that from the output, from the regression output, they're all, the AR one step is significant. The MA one step is significant. And it's a nice fit here, right? Forecast and reported. Okay. So next thing we might want to look at is, again, do we have a constant mean? Are we wrapping around zero? You know, the error terms are supposed to be normally distributed. Are we seeing kind of a bell-shaped curve? And we are. So we should feel reasonably good about this. Here is validating your model. So usually what happens about this step is you have a set of data and you're going to break out a certain part of that data to train your model, if you will, right? So you take a portion of it, and you can see that in blue here, and we've taken that portion of data and trained our model on this ARIMA 111. And then the other portion, what you're seeing green and yellow, is the yellow is the actual data, and then the green is our forecast using the ARIMA 111. And you can see it's kind of like a straight line. And if you remember looking at Thomas's SEER model, since we're keeping it simple and we're only going out a couple weeks, kind of looks similar. We're not getting crazy. And again, this is a univariate, very simple model. So simple models can be very useful. Now we're going to step into auto ARIMA. So this is the PMD ARIMA from Python. And what it does is you set a certain amount of certain conditions, and it runs through all these models for you. It picks out based on maybe some kind of information criterion, Bayesian or some other. And you can see here in red, it's got the minimum one picked right here. And this is an ARIMA 213. So remember, we started off with our visual, our eyes, and my eyes hurt right now, so they're not so great picking those steps. And I picked a 111. Well, it looks like a 213 is better. So what happens if we walk through the same procedure with this? Well, we can see that it's not just a straight line anymore. Now it's getting a little bit tighter on the curves of the actual data. Okay, so then once you've built your best model, then you can forecast out. And here's it forecasting out a couple weeks like we're doing here in Hawaii. And again, this was done for these grad students to give them something to play with, and I left them all the code. I think that's pretty much what I came to share, Thomas. So if anyone has any questions, I'll stop sharing.
Thanks so much, Tom. For me, it's been a while since I've got my hands down and dirty in the modeling. Levi's been great, and Bobby did a lot of work as well. And then now that we have you, we've always had you and Lee and now Monique. I feel like you guys are the experts when it comes to the modeling, and I add the FE perspective. But I learned a lot, and hopefully the group here, especially those who may not have as much experience in modeling and the forecasting, have a better appreciation of the nuances and just how difficult it is to give a straight answer. I think people always ask, okay, is it going up or is it going down? As if it's a binary question, with a binary response. And, it's it's like forecasting whether or not we'll have a hurricane 2 months out, but we want the answer today. And so, and we actually can do that probably better with the hurricanes than we can with COVID. So hopefully everybody has had a chance to just get a better appreciation for, the group of the work of HiPAM as a collective, and also our individual experts, and also the limitations of what modeling and forecasting have, and therefore the uses, the usefulness it can provide for policymakers and also for other decision makers. But it's great tools, but they're just tools, for better or for worse. So yeah, no, I'm very appreciative, Tom. Are there any questions from the group? I know Tom did a great job keeping it very at a very high level and not getting in the weeds. Though if some of you do want to get in the weeds, I'm sure you can reach out to Tom, and we'll make the PowerPoint. I will make the slide deck available on our website right afterwards if it's not already updated for you to take a look and to play around with it if you have Python experience or not. I'll wait a little bit for any for questions from the group. And it doesn't have to be for Tom specifically. If there's any questions you have on variants or vaccine trials or anything, there's been a lot recently about, double masks. Do we need to start wearing 2 masks because of the variants? What type of mask? I feel like we're just going to circle back to which masks are appropriate. And then for some of our federal and DoD colleagues on the line, the Secretary of Defense just released an updated memo today, hot off the press, that provides updated guidance to reflect the president's mask wearing guidance and initiative. So if you're on federal property now, especially if you're in uniform, you have to wear a mask at all times, outside and also indoors, unless you're in your own enclosed space. And I know we've had a lot of talk within our HiPAM group in terms of ventilation being a large part, not just wearing masks. So, but I think there's been a lot of gray area, not just within the federal space, but just state space. If you try to look at, okay, when do I wear a mask indoors? The states, I think COVID-19 now, or COVID19.org, doesn't provide very clear guidance. It just says when you can't physically distance for 6 feet, wear a mask. But that can be taken so many ways. So at least from a federal level, there's been a little more clear. There's been clearer guidance that just came out in terms of indoor mask wearing usage. And we know that can reduce transmission, but ultimately it's that plus ventilation. So it's a continuing effort to stay educated with the best up-to-date guidance, and that's really all we can do. So I will pause for any other questions, and if not, I don't see any. You can either raise your hand or post them in the Q&A. Once again, for our newer members, if you go to our website, hipam.org, on the upper right-hand corner, it says, I can't remember what it says, community work group or something to that effect, and you can see our archive of all of our presentations, recordings, and also our slide deck. So with that, let me see. Oh, thanks for posting that, Rukia. With that, I will adjourn our webinar for today. Thank you, everybody, for participating. Thank you again. Special thanks to Tom. I learned a lot, as always, and we will see you guys next week, Thursday. For anybody that are attending, if you have questions, please send them to our email. Oh, we have a question from Jim. Is there any work to use data to better understand the role of travel in our case numbers to do a contact tracing? That's a great question, Jim. I haven't had a chance to spend as much time on the state perspective. I know we have Dr. Josh Quint from DOH on if you want to take a stab, Josh, or we can always provide a written response as well. Let me see if Rukia. Oh, perfect.
Yeah, could you repeat the question?
Yeah, of course. So, question from Jim. Is there any work currently, I'm paraphrasing, to use data to better understand the role of travel and the impact in our case numbers? The contact tracing data leaves some doubts that the Safe Travels program is working.
Yeah, it's a hard question. I think it goes back to your point of, is it working or not working? But that's a false dichotomy. It's how well is it working? And I would say what DOH and DocD produces is the case data stratified by travel and resident status. And so that's available and can be incorporated into models for people who are interested in understanding how that may have affected. What we see qualitatively is there was that surge following Christmas and New Year's, and that was kind of general. I think I saw it in the New York Times or someone showed like, okay, what is the Super Bowl going to do? There seems to be this holiday impact of, we know people gather, it's hard to resist that. And then, yeah, thanks for pulling it up. Yeah, that's what I'm describing here. So we know people gather, it's hard to resist gathering, and we have our, cultural practices that we have, whether it's Super Bowl Sunday or Christmas or New Year's. So, I think there was much of the surge at the beginning of the year, a month ago, 2 months ago, was related to travel, but then it calmed back down as travel seemed to go down. So, had a noticeable impact, but not nothing like what we saw in August.
Yeah, and we have a follow-up question from Jim, but before I lose my train of thought, to add on to what Josh said really well, contact tracing is hard no matter how many people you have, and if you even have the best technology, it's just it's always difficult. And so Josh, please let me know if I'm misinterpreting what you told me previously, in that it only goes back one quote unquote iteration or generation in terms of connecting it to travel. So while someone could have been responsible for a cluster and that person was travel related, it's just so difficult to pinpoint it back to that one traveler. So there's some give and take in terms of the travel associated piece. So it's just and it's of no one's fault. It's just a limitation of contact tracing. So once again, it could be a little bigger, it could be a little less. It's just part of working with data in real time with real life limitations that are of no one's fault. So
that's right. Yeah, a couple of issues I would add on to that is, at what point, where do you set the cutoff of what a case is travel associated? Because all cases are travel associated, right? And so it becomes difficult to set boundaries and thresholds for. So how we've defined it for this chart, because it's what we can reliably do, is to go one generation back. And now we recognize that, what we're calling community in this chart, that's according to a specific definition that's very dictated by our capabilities, and being able to go back in time and to track, like you pointed out, that is going to be difficult, and unless we sequenced every single case and got their viral loads. And an example is, if you think back over the past 10 years, whenever you've gotten the flu or gotten sick, how frequently did you know who gave you that sickness? Sometimes it was maybe a family member and you had a high probability, but a lot of times, with respiratory diseases, they're just out in the community, and so it's difficult to pinpoint exactly how we got sick.
Yeah, 100% agree, Josh. Follow up from Jim. Does this explain, what we have seen in Kauai County? And I wish Janet were here, because she's the foremost expert on Kauai for our group. But so I pulled up, stratified by Kauai County. Josh, I don't know if you have any insights for travel related specifically to Kauai.
Yeah, it's tricky. There's such small numbers, hard to draw a lot of conclusions. I mean, you do see travel predominating there's a lot of blue there. It might be more helpful to look at the table view since we're dealing with small numbers. Sorry, top right corner.
Oh.
Below that, it says click to view table below.
Oh,
right
got it.
there.
Sorry.
Yeah.
Here we go.
And so it gives you the counts. So sometimes risk factor is not known. Kauai, they're pretty on top. They always figure out the risk factor of their cases because any one case is high profile. And then you can see the percent community and those percentages over time versus travel. So, kind of draw your own conclusions. A lot of what we do in DocDia is making that data very available and accessible so that people can be informed and get the answers that they're asking.
Perfect. Thanks so much, Josh. And thanks for the questions, Jim. I'm going to see. I don't see any other questions. Once again, for our attendees and for our members, if you have any questions, I know I regularly ask, Marguerite. I'm not sure if I saw, about variants, because this is, she's the expert in HiPAM, and she has colleagues who are virologists that she can ask. But, variants are a huge area of interest now, and I think for a long time moving forward. And then we have our modeling experts. So once again, we have a wide array of expertise that are part of HiPAM. And if you have questions, and please don't feel as if, it can be the simplest of questions that you would like some clarity on. And that could spark a webinar series. So please, if you have questions, just email email us, HiPAM, and you can find that on our website. And we're always here to help educate and work with the community group. So with that, no other questions. Thank you everybody for your time. Have a great weekend, and we will see you next week, Thursday. Mahalo.